Wonderful and caring friends, welcome to Planet Earth, our loving home, on Supreme Master Television. This week we are fortunate to speak with Dr. Peter Barrett, Professor of Geology and Director of the Antarctic Research Centre at Victoria University of Wellington in New Zealand. Professor Barrett has spent over 4 decades studying the Antarctic, with a particular interest in its historical evolution over time. In the 1960s, Professor Barrett spent 5 years at Ohio State University, USA, where he completed his doctorate. He also worked in Antarctica, mapping the continent's mountains, and thus became fascinated by the ancient history of the region. When he returned to New Zealand, he took part in a deep-sea geological drilling expedition of the ocean floor near the Antarctic. He discovered that core samples obtained from drilling are the key way to trace the past of the Antarctic continent. Currently, Professor Barrett is taking ice core samples in the Antarctic to better understand the climatic and chemical changes that have occurred in the area over time.
You've been working on several Antarctic drilling projects for the last 30 years or so. Can you tell us how these projects help us to understand Earth's past and present climate?
The polar regions are particularly sensitive parts of the planet. Most of the heat comes in from the sun in the tropics. It gets circulated down to the poles, but changes are greater in the polar regions than they are in the more central part of the Earth. And what the drilling does is to actually get us a history of climate going back in time. And because the Antarctic is mostly covered with ice, we can't use exposed rocks like you do on other continents, so drilling is so important.
Professor Barrett is also investigating the effects of global warming on the Earth's ice sheets and the subsequent rises in sea levels. Dr. Jays Wiley, a leading American climatologist with the National Aeronautics and Space Administration, or NASA, in the United States, has stated that the Arctic could be ice-free by the summer of 2012. Professor Peter Barrett shared with us the possible repercussions of such an event.
There will be quite profound consequences, but perhaps first it's important to say that the changes there are taking place faster than predicted, that our understanding of 10 years ago suggested that this melting wouldn't take place until later this century. But we are gaining knowledge so quickly now, it's important to realize that we must sort of stay apace with this knowledge so that we can make better judgments about the future.
Although much discussion has occurred regarding the melting of the Greenland ice sheets, the disintegration of the ice at the Antarctic is also a significant marker of global warming. This precious place contains 90% of the world's ice and thus holds most of its freshwater reserves. If the Antarctic were to completely melt, it could potentially cause a 190-foot or 58-metre rise in sea level. This figure does not take into account thermal expansion or the increase in the volume of water when it is heated, which could further raise the height of the ocean.
Well, in the last 4 years, the scientific reports, not only from the Antarctic, though these are serious, but also from the tropical regions, make it quite clear that it's human CO2 or greenhouse gas emissions that are causing these changes that we're observing. And I'm just mindful of the Nobel Peace Prize that was awarded to Al Gore and the Intergovernmental Panel on Climate Change. It was a peace prize because of the work that committee has done to understand and advocate for the management of the climate problem.
The The Antarctic can be divided into three main areas: the Peninsula, the West Antarctic and the East Antarctic. In March 2008, a large part of the Wilkins ice shelf located in the peninsula, measuring about 405 square kilometres, separated from the peninsula. In January 2009, it was reported that the entire shelf, which measures more than 14,000 square kilometres, is near total collapse.
In the case of the Wilkins ice shelf, this is significant because the Antarctic Peninsula is warming faster than almost anywhere else on Earth. The warming rate, well, it's like 2.5 degrees in the last 50 years. That's also true of the Arctic and Siberia, but most of the rest of the Earth is not that fast. And that is now recognised as a response to this warming, which itself is a part of the larger global warming that we're now starting to experience. So, if you like, it represents a warning. With the knowledge that we now have of Earth history and carbon dioxide levels in the past, it's quite plain that we are moving now into a very dangerous period of climate change. In our own work in Antarctica, the West Antarctic ice sheet collapsed, or somebody wasn't present. We have good records of this 3 or 4 million years ago, at a time when CO2 levels were less than 400 parts per million, and we're now approaching that. Now, this is a situation where we don't expect that the moment it reaches that point, the Antarctic will respond. But what it does mean is that we have actually the climate in which that will eventually take place. First, the sequence is very clear. The ice shelves break out first, and you mentioned the Wilkins ice shelf. That's further north, but that's already happening. The Ross ice shelf is much bigger. It will need a rise in temperature of that region of 4 or 5 degrees. But that could happen within a few decades. And then once that goes, that releases the ice in West Antarctica. So it's hard to say what's worse, it actually happening now, or a civilization that lives in the knowledge that it will happen and that sea level will rise 10 or 15 metres as a consequence.
Please stay tuned to Supreme Master Television. We'll be right back with more insightful information on the future of the Antarctic from Professor Peter Barrett.